Hello and welcome back to my top-down snowman survival series. This is part 7. In the last part we made the gems spawn in, and in this part we're going to be picking them up. Earlier on in the series we had the enemies detect a collision with the bullets. We're going to basically do the same thing with the player, so this should be fairly familiar. On the player, all we're going to do is we're going to add ourselves an Area 2D node that's going to be our detector. I'm going to rename that to hitbox as well as I did with the other one. The hitbox also needs to have some sort of collision shape, so I'm just going to choose the collision shape that matches the player. So I'm going to choose this capsule shape again. I'm just going to drag this so that it is bigger and it's on the outside of the player, so that this area, when something goes into it, will be able to detect it. And then we're going to connect this up to the actual player script to keep it really simple. So the player script up here, if I click on the player script, all we've got really is the movement system, but we're going to connect up a function to this when we get this event for the area entered. The hitbox over here, if we click up to node, we can see we have this area entered function, just like we used before, this signal. This, if we connect this straight up to the player, it will create a on hitbox area entered function for us that will run every time something enters that hitbox. Remember from the last time we were able to print basically the name of the area that went into it. If we do quickly test this again, you'll see that anytime we go into something, including the snowmen or the bullets themselves, these all fire. So we don't want to do anything when the wrong things are going in. We want to make sure that it's actually the gems that are going in so that we can pick them up. The way we did it last time was by having a script on the object that we wanted to check. It was the bullet in our case, but we don't have a script on the gold. You'll see that there's actually no script on the gold, on the coins. So all I'm going to do is I'm going to have to make myself one. I'm just going to choose the correct location rather than putting it in the scenes folder. Put it in the scripts folder. This one is going to be called gold.gd, so I'm going to create this script. It doesn't really need anything. All we need it for right now is, we could do lots of stuff in here, but all we need it for right now is to have the class name. And usually the convention is that it's the same as the item, but it's a capital G for the class name. So all it is a class name gold. So every time we spawn a gold in, we should have this class name of gold, so we can check that within our script. So like before, if we go back into the player script now, when this hitbox has this area entered, we want to just check to see if it's an actual gold. So we'll just say if area is gold, and that's the class name that we used, and we can print something like a little message like collected gold. Let's just test this to make sure that this works. Obviously, when I can spell correctly, we will test that this works, and just hit the play, and what we should see is only a message when we collect one of the gems. It should say collected gold. So what do we want to do with that information? Well, we want to obviously have some sort of score. Now, I'm going to do this the simplest way, but it's not the best way. We're going to keep the score on the player. So all I'm going to do is I'm going to create a variable called score and make it initialized to 0 at the beginning. So every time we collect a gold, we're going to print collected gold, and we're just going to make the score go up by 1. So we just say score plus equals 1. So this value will change, and the issue is that we want to do a couple of things with that. The first thing that we're going to do is we're going to change the number of bullets that the gun actually fires based on that score. This gives me an opportunity to talk about some really important concept within Godot. So one of the key things, we have our player here. One of the key things in Godot is about calling down and signaling up. So the ways to communicate from node to node, if you have a node that is a parent of another node, like we have here with our gun, it's perfectly okay to just call down into that. So we can make a call down into a child object of this main object, even if it's a scene on its own. We also have this situation right now where we have the hitbox, and that's signaling up. In theory, you could do the ... and then call the player, sort of like call a function on the player from the hitbox. But Godot recommends that the best practice is to call down. to call down into children, but when you're calling from a child up to another object or even a sister or a sibling, you can signal up, and we've done that already with the signal that we used with the hitbox. So what does that look like in code? Well, we remember from the gun script that we have, the gun has this number of bullets, and we set it to 8, and it'll shoot 8 bullets. What we're going to do is the player is going to call down to the gun, and we're going to change this value. So let's just try and get this working in the simplest possible way before we tweak it. Right now the score does go up, but what we should do is we should call down to the gun, and to set the number of bullets, if we remember from our script, we have this num bullets. While I'm here, I'm going to actually just change num bullets to be equal to 1. So the default starting one is 1. Then inside of my player script, just after we've updated the score, we're just going to say that we want to drill down with the $sign. So this is how you call down into children objects. You'll see all of the children that are part of this player, children of this player, they're all listed here. And I can choose the gun because I want to set the gun, and then I'm going to do the dot, and then I'm just going to find that variable, so num bullets. I'm going to make it equal to the score plus 1, so we've always got at least 1 bullet, and then every time the score goes up we get an extra bullet. So we'll quickly test it. I'm sure I've missed something, but let's just give it a go anyway. So right now, 1 bullet, and then we're just going to kill a snowman and then try and pick up some coins. And you'll see that we suddenly got an awful lot of bullets. I think what we've maybe done, if you probably realise this mistake, is that we probably forget to delete these coins, these gold, when we pick them up. So let's just go and fix that, otherwise it's kind of unplayable. So back in this player script, when we have collected the coin, which is called area, we'll just, actually we'll do this at the very end of the code. So we'll just say area.queue_free, and that will get rid of that gold from the scene, and hopefully we won't pick it up a second time. So we'll take a little look at this, see if this works. So there we go, we have 1, we pick it up, and obviously we've got 3 now, and let's test again. So that's now 4, and then we should pick up, oh, I picked up 2 more, so that should be 6, sorry. And there we go. So it looks like everything is working as expected for this. Before we finish, let's just tidy up some of this. Calling this is apparently not great. It's apparently quite costly. So we can actually cache this value so that it's only done once. The way you do that is at the beginning, you do an onReady. So this is effectively the same as putting it in a ready function. It'll be done when the game object first comes into the scene. So we'll say @onReady, then we'll create a variable and we'll call it gun, and we'll make it equal to $gun. That way we're kind of storing that reference at the very beginning, so we don't have to do it here. That way we can change this to $sign just to gun, and then gun.numBullets equals score plus 1. The next thing would be to just to try and have some sort of a gameplay element here where we just change the amount of bullets that this goes up by. Obviously, every time you score 1, when you go up 1 more bullet, it's going to be a little bit unplayable. So we want to have some way of sorting that out. And this allows me to introduce the really cool graphing tool called Desmos. You didn't think you'd be doing maths today. So the classic line equation y equals mx plus c is kind of what we want. I created some sliders just real quickly for each of these, so we can use this to kind of work out what we want for our graph. So in theory, when we have a score of 0, so let's imagine that the score is across the bottom here. So when we have a score of 0, the number of bullets that we're firing we want to be 1. So you can see that that's what we have with a standard y equals mx plus c, where c is equal to 1. The m is the gradient, so how quickly we want the score to go up. So right now with a an M value, a gradient value of 1, then it will go up by 1 every single time we add 1 to the score. So we want to have a smaller value. If you see what happens when I change this to something like 0.2, what we end up having is as the score goes up and up and up, so you have 5 bullets by the time you get to 20, by the time you get to 40, you've got just under 10, it's like 9 bullets, and you have to be up to a score of 70 before you get up to 15 bullets. That's not bad. I think the value of 0.2 might work quite well, but obviously you can change this and tweak this in code. Let's see what that looks like when we code it. So it's pretty easy. If we just go back into our player script here, just where we're improving the or increasing the number of bullets, rather than do it linearly, we'll just do that 0.2 value that we did. So we're multiplying score by 0.2, and we're adding on that 1, so it's always above 1. Now, in testing, I discovered that you need to make sure that you turn this into an integer value, because this is 0.2 is obviously not a whole number, so it's not going to get a whole number when you get the result, and that causes some issues at the other end when we use it on the gun script. So this int function with the brackets around the calculation there, that just makes sure it's an integer. The last thing we can do is we don't want it to go too high. So what we can actually say is we can say num.gumbullets equals clamp, and we can clamp the values between a minimum and a maximum. So what we'll say is we'll take we use the clamp function and clamp the value numbullets to a minimum of 1 and a maximum of, I don't know, we'll do 12 or 18 or something like that. You can tweak that value as much as you like, so that so that no matter what the score is, it'll only max out at 12 bullets. Alright, so feel free to test that and tweak those values to see if the gameplay is good for you. Don't forget that the enemy spawner also has if you go to the enemy spawner, it also has a timer. And so the timer value you can change based on the enemy spawner, so you can have those changed. And before I move on, also I think we'll put some more enemy spawners on the scene. So let's not put them there. We'll click on the top level object and just drag on an enemy spawner and drop it in like this. So we've got maybe 4 spawners that spawn in our snowmen, and then you can play around with the values for the spawn rates and the values for the bullet timer too. And I think I've done enough maths for today, so we'll call it quits there. I hope you're enjoying the series, and stay tuned for the next one. In the next one, we're going to be making some UI so that we display the score on the screen. See you in the next one.